Hi, we are going to talk about one-sided limits. So there's situations when we try to evaluate the limit as we approach a certain value from one or the other side, just left or right, and we call them one-sided limits. First of all, the notation that we use. This notation here, you can probably see that A has a little minus sign written slightly above that in superscript notation. And so this is what we call the left-hand limit, and we read that the limit of f of x as x approaches a from the left. And then this notation with a little plus, we read that as the limit of f of x as x approaches a from the right. So the negative sign does not have anything to do with positive and negative numbers. Positive numbers simply says that we approach from the side with bigger values, so from the right. And the negative sign indicates that we approach the number from a side with smaller values, from the left. We can use one-sided limits with any types of functions, but a lot of times they're used for piecewise functions. So let's take a look. So here's a piecewise function, defined as follows. And what we're trying to do here is evaluate well, first of all, evaluate f of 4 from your previous math classes. You should find this fairly simple task. So f of 4, where does 4 belong? It belongs here. So you substitute 4 into the first function. So 2 times 4 minus 1, that will give you 8 minus 1, which will be 7. But now let's talk about the limit. So we're trying to evaluate the limit of the function as x approaches 4 from the left. So from the left, we're still going to be with this function here because less than 4, not equal 4, but less than 4 is here. So since less than 4 is here, we can actually use direct substitution here to do this. But we have to use this function because the values that are smaller than 4 are here. So that means we are going to have 7 as well. Now let's take a look at the let's see. So here we're approaching 4 from the right. So from the right, we have to have values greater than 4, so that's this one. So it's going to be 1 minus 4, which will give us negative 3. Okay. Again, let me give you a quick rundown about the limits. So this here is asking you to evaluate the limit of f of x as x approaches 4 from the left, as indicated by a little minus sign. So the left side of 4 is the first equation. And here we're trying to find the limit of f of x as x approaches 4 from the right. That's the second equation. Okay. Moving on, another example. The limit, so we have some function g of x defined as follows. So the first thing we need to do is evaluate g of negative 1. So here, greater than or equal to negative 1, the value of the function is always going to be 1. So that one falls here, and the answer is 1. Now about the limits. So the limit of g of x as x approaches negative 1 from the left. From the left is going to be here, where the less than negative 1 is. So we're going to substitute negative 1 into this function. So negative 1 squared is 1, 1 minus 2 is negative 1. So the answer here is going to be negative 1. Okay? And C, we have to evaluate the limit of g of x as x approaches negative 1 from the right. From the right is here. The values that are greater than negative 1 are here. And the answer is going to be 1. Okay, so again, remember when you try to evaluate one-sided limit, you have to find the side where the number is going to be greater than or less than, depending on whether you're dealing with left or right-hand limit, and then evaluate the function based on that. Okay, another example. So this one's a little busier. As you can see, defined by 3 different functions. And that's what we are going to do. So we're going to go ahead and start from the beginning. So this one's asking us to find the limit of f of x as x approaches 2 from the left. So where is the left of 2? when it's less than 2, which is here. So 2 is going to be substituted into this function. So 1 minus 2 squared will give us 1 minus 4, which is negative 3. What about f of 2? Well, that's just a simple question of where 2 is. 2 is here, so it's actually going to give us the same exact answer. We will take 2, substitute it into the first equation, and we will also get negative 3. But now we have to find the limit of this function as x approaches 2 from the right. So from the right, this is the part where x is greater than 2. So as x approaches 2 from the right, the value of f is going to approach this number here, which is negative 1. Okay. Now we have to figure out the limit of f of x as x approaches 3 from the left. So 3 from the left, we're still here, because less than 3 is here. Okay. This part is irrelevant for that. But here we're approaching, if we want to approach 3 from the left, we're going to be here, and the value is going to be negative 1 as well. F of 3. Interesting enough, but f of 3, because less than or equal to 3 is here, so f of 3 is also negative 1. And lastly, for this function, the limit of f of x as x approaches 3 from the right. So I hope you understand it better now. From the right of 3 is here, so we're going to plug in 3 into this function. That will give us positive 1. 2 times 3 is 6, minus 5 is 1. There are a couple more functions that are commonly used in textbook, as textbook examples. And I'm going to show you those. So one of those functions is what they call the greatest integer function, or the floor function. This is the function where the input is a real number, and the output is going to be an integer that is less than or equal to the given value of x. It is, of course, easier to work with those things in with graphs, but you should be able to figure it out without the graph as well. If you want to learn more about these functions, you have to look up specifically what they are. But that's the notation. So please note it looks like a bracket, but it's actually doesn't have anything on top. It just has the bottom part. So when you evaluate g of 1, so what does that mean? We want to find the value of an integer value that is going to be less than or equal to that number, which I think it's pretty obvious is going to be 1, because 1 is an integer and 1 does not exceed 1 that's given to us. Okay? But when you try to evaluate the limit of this function as you approach 1 from the left. So when you approach 1 from the left, you think of numbers like 0.9, 0.99, numbers like that. So each one of these numbers is going to be less than 1. That means that the integer that each one of these numbers is not going to exceed is going to be 0. Because like numbers like 0.99, for example, if we analyze that, that number is not going to be greater than or equal to 1. That number is going to be, less than or equal to 1. It's going to be less than or equal to 0. So the answer here is going to be 0. You can also see from the graph right here, that's where 0.99 roughly is going to be. So right here the value is 0. But when you try to approach the same value from the right, so now you have numbers that are slightly higher than 1, like 1.01 for example. And for 1.01, those numbers, the integer that's going to be less than or equal to that number is going to be 1. So here it is 1. These functions can be somewhat confusing, so you may want to research them first if you want to understand this better. There's one more that I'm going to show you to wrap this up. The other function is what they call the least integer, what they call it the ceiling function. The notation is like that. The graph looks very similar, although you will notice where the location of the closed circles is. So what we're dealing with here, we're dealing with the function where the outcome is going to be an integer that's going to be it's going to be greater than or equal to the given value, the closest integer. So if -2, think about what integer value is going to be less than or equal to -2. That value is going to actually be -2. That's easy. But now we have to look at this. Same thing, but we're trying to find the limit as we approach -2 from the left. So think about numbers like -2.1. So an integer value that is going to be -2 or well, less than -2 is going to actually be -2 as well. So we're looking for a value that's greater than or equal to. And with -2 approaching from the right, that's here, if you look at the graph. So what integer is, so think about numbers like -1.9. What integer is going to be greater than or equal to that number? That's actually going to be -1. Again, these functions, if you're not familiar with them, it would be helpful to research them first before delving into this. But this is how it works with one-sided limits. I hope this helps.